Hi guys, this is Mrs. Rooker. I'm going to be doing the day 5 notes. So the first thing I want you to do is pause the video and do the review problem, and then unpause it and I'll show you my solution. Alright, so it says to factor the following using imaginary numbers. So we have 9x squared plus 49. And we learned earlier about difference of perfect squares. If you look at these are both perfect squares. But in order to use difference of perfect squares, you need a difference. A difference means a subtraction problem. So I'm going to rewrite this as 9x squared minus negative 49. It is now a difference of perfect squares because I have a subtraction problem. To factor a difference of perfect squares, it's a squared minus b squared equals a plus b times a minus b, which basically means I square root the 9x squared, which is going to be 3x, and then I square root the negative 49. Square root of negative 49 is 7i. Square root of a negative is I. And then it's going to be 3x minus 7i, because that's difference of perfect squares. It's plus and minus, which is answer option C. Alright, so today we are going to review a little bit, and then we'll get into solving using square roots. So we're just going to practice simplifying. Two options when you're simplifying. One is to make a big factor tree. The other option is to find the largest perfect squares that go into a certain number. So 24. Off the top of my head, I can't think of any super big perfect squares that go into 24. I do know 4 goes into it. That's a perfect square. 4 times 6 is 24. 4 breaks into 2 and 2. I would keep breaking 6 down, but I know that 6 only breaks into 2 and 3. And that won't give me any more pairs, so I'm just going to stop. The 2 comes out, the 6 stays in. So remember, pairs can come out. Alright, same thing with 98, although I do know there's a pretty big perfect square that goes into it. I know that if I divide 98 by 2, I get 49, which is really nice. The square root of 49 is 7, so this breaks into 7 and 7. 7 comes out. 2 is left over. Alright, on something like this, I would want to reduce the fraction first to make my life easier if the fraction could reduce, but nothing goes into both 17 and 16, so I can't reduce the fraction first. I'm going to split this into 2 different radicals, square root of 17 over square root of 16. 16 can reduce, square root of 16 is 4. Remember, when I take the square root, the root symbol goes away. Root 17 stays on top. 17 is actually a prime number, so it can't break down. So we're done. On this one, I would try to break down 5 first, but 5 is prime, it doesn't break down. The one issue with this is I'm not allowed to have a radical on the denominator. To get rid of the radical on the bottom, I multiply top and bottom by itself. I end up with 6 root 5, because remember, this is outside of jail, this is inside of jail, they can't mix, so they stay separate. Root 5 times root 5 is root 25. Square root of 25 is just 5. That's our final answer. Please do not reduce the 5s. Root 5 is not the same as normal 5, so they cannot reduce. Alright. Next one. So here's an example of one where it's going to save yourself a lot of time if you reduce the fraction first before the radical. So we're just reducing 8/12 first. What goes into both 8 and 12? They both are divisible by 4. 8 divided by 4 is 2, and 12 divided by 4 is 3. Oops, 3, sorry. 3. But remember, we didn't deal with the radicals yet. They both still have radicals on them. All right, and then the last thing you're going to need to do is get rid of the radical on the bottom. Remember, we're not allowed to have a root on the bottom. To get rid of the root on the bottom, you multiply top and bottom by root 3. We end up getting root 6 over root 3 times root 3 is root 9, which is just 3. We cannot reduce these two because root 6 is under a radical, it's in jail, and 3 is not, so they can't mix. Okay. Next one, again, we don't like having a radical on the bottom, but on this particular one, we can't just multiply top and bottom by root 5, because then we'll end up with a root on this one. So we have to multiply by the conjugate. Remember, the conjugate is the same numbers, but we switch the sign in the middle. So 4 minus root 5. Whatever I do on bottom, I do on top. On the top, we just distribute. We just have one term that we have to distribute into the binomial, into the two terms. Root 2 times 4 is 4 root 2. They can't actually physically multiply because one's in jail and one's not. Then we multiply the root 2 by the root 5. Those actually do multiply because they're both inside the jail. Right? And then we put that over. On the bottom, I have 2 terms times 2 terms, which means I need to FOIL or double distribute, whatever you call it. So I multiply the 4 by both terms first. So 4 times 4 is 16. 4 times root 5 is 4 root 5. Then I multiply the root 5 by both terms. Root 5 times 4. Oops, I just messed something up. The second one was a negative root 5. So 4 times negative root 5 is negative 4 root 5. Sorry about that. And then I do root 5 times 4, that's a positive 4 root 5. And then root 5 times negative root 5 is negative root 25, which can simplify, so we'll do that next. These middle terms cancel. Root 25 is just 5, so that becomes minus 5. 16 minus 5 is 11 on the bottom. I would look at the top and try to reduce, but 10 only breaks into 2 and 5. There's no pairs there, so I just leave it as 10. 4 root 2 plus root 10. Please do not combine these. You can only add them if they have the same number under the radical. It's like having like terms. All right, looks like one more review problem. So same thing, I need to get rid of the radical on the bottom. So I multiply by the conjugate. The conjugate is going to be the same numbers, but I change the sign in the middle. So 2 plus root 7. Because these are 2 terms on both, 2 terms times 2 terms, I need to FOIL both of them. So for the top, 5 times 2 is 10. 5 times root 7 is 5 root 7. Root 3 times 2 is 2 root 3. And then root 3 times 7, root 3 times 7 is root 21. Over the bottom, 2 times 2 is 4. 2 times root 7 is 2 root 7. Negative 7 root 7 times 2 is negative 2 root 7. And negative root 7 times positive root 7 is negative root 49. Now let's simplify the bottom, well, and the top if possible. Middle term should always cancel when you're multiplying by the conjugate. This becomes negative 7 instead of negative root 49. Then we have 4 minus 7 is negative 3 on the bottom. On the top, I would try to break down the radicals. Root 7 doesn't break down, root 3 doesn't break down, root 21 breaks into 7 and 3. There are no pairs, so we can't reduce it. We cannot add them together because they are different numbers under the radical. So this is just a long, somewhat ugly answer. And we're done. So that, oh, I didn't mean to cross that out. I meant to highlight it. That is the answer. All right, so now we're switching gears to the meat of the lesson. We are going to use square roots to solve these problems. I only use this method if there is no b term. What I mean by that is if I have something like this, x squared plus 5x plus 7 equals 0, I cannot solve by square rooting because there is a b term, there's an x term. I'm only allowed to do it if I have something like this, x squared plus 7 equals 0. Okay, I can only have an x squared, I cannot have just an x. The reason is because if I try to square root, I'm going to end up with a square root of x, which I don't want a square root of x in my answer. So only use this method if you have an x squared but no x. So this method is kind of like old school solving, like you learned in the beginning of Algebra 1. To solve, the goal is to get x by itself. We're trying to move things away from the x. We use reverse Pemdas when we're trying to solve, which means opposite of Pemdas. So instead of dealing with the exponent first, we deal with multiplication or division. So I need to move things away from the x. I want to move the 3 away. This is 3 times x. The opposite of multiplying by 3 is to divide by 3. Whatever I do on one side of the equals, I do on the other side of the equals. Those cancel. I'm left with x squared equals 25. Last step to get x by itself is I have to do the opposite of squaring. The opposite of squaring is square rooting. Whoops. Square rooting. And my pen's glitching out a little bit. Whenever I square root, I need to put a plus or minus in front. So my answer is x equals plus or minus 5. That means that I could plug in a positive 5 and it would work. I could also plug in a negative 5 and it would work. That's because negative 5 squared is the same as positive 5 squared. So each of them would work. I need to include both answers. You should get 2 answers on almost all of these. All right, next one, same thing, move things away from the z. First thing I move is the 7. Add 7, add 7. Z squared equals 32. Next step, square root both sides to get rid of the squared. Z equals plus or minus, oops, I forgot to write that right here. Always put a plus or minus in front of the square root. Then you need to reduce root 32. The biggest perfect square that goes into 32 is 16. It's the same as 16 times 2. This breaks into 4 and 4. 4 comes out, 2 stays in. If you don't have all your perfect squares memorized or you didn't know that 16 goes into 32, that's okay. You could break it down a different way. But that is your answer. So again, I'm trying to move things away from the x. Reverse Pemdas means I'm going to deal with addition and subtraction before anything else here. So I'm going to add the 6 to get rid of the 6. Whatever I do to one side, I do to the other. So I have x squared over 25 equals negative 4. Then I want to get rid of the 25. Right now this is x squared divided by 25. The opposite of dividing by 25 is multiplying by 25. So if I multiply by 25, that will cancel out, and I'll be left with x squared equals negative 100. Next step, to get rid of the squared, the opposite of squaring is square rooting. Every single time you put a plus or minus in front of the square root, x equals, sorry, I forgot to mention, the squared and the square root symbol cancel each other out, so that's why we're left with just x, equals plus or minus, the square root of 100 is 10, and the square root of a negative is always I. So that's why we have plus or minus 10i. I went way faster than I thought I was going to go on these. The last one. It's the same process. We need to try to move things away from the x. For some reason, a lot of people are really tempted to take this and FOIL it out. You don't need to go to all that work. If you do all that work, you won't be able to use the solve by square rooting method. You'll have to FOIL it out, then you'll have to factor or use quadratic formula, and it's just a big pain. So So if you see something like this, if there is only x written once, we have x here and it's squared, and you don't have another x written, you can use the solve by square rooting method. And we just move things away from the x. The first thing we can move is the 7. So minus 7. I'm left with x plus 4, that whole thing squared, equals negative 72. Then I cannot move the 4 because the 4 is being squared. So I can't move that until after I've moved the squared. To get rid of a squared, I have to do the opposite of squaring, which again is square rooting. Whenever I square root, I put a plus or minus in front. That's going to cancel out the squared. So all that's left on the left side is x plus 4. And then I have plus or minus. And then I have root negative 72. I'm going to break down 72. Think about perfect squares that go into 72. I know 9 goes in, but I'm thinking even bigger. Think of your perfect squares. We have 9, we have 16, we have 25, we have 36, which does go in 2 times. 36 goes in 2 times. If you had done 9, that's fine. You just would have had to break down more things, or more times to get everything out of the radical. 6 comes out, 2 stays in. Oops, I forgot that it was a negative 72. If you have a negative, an I has to come out as well. So 6i root 2. All right, we're almost done, but x is not by itself. We're trying to get x by itself. We still need to move the 4. In order to move the 4, I do opposite. Minus 4, minus 4. The proper way to write your answer is going to be x equals negative 4 plus or minus 6i root 2. Whenever you have a plus or minus there, if you end up adding or subtracting something to that side, you put that number in front of the plus or minus is the proper form. All right, so that is our answer. All right, please come with questions to class tomorrow. Ask your teacher if you didn't understand anything. Thank you, guys.